Okay, 6.4, page 289, exercise 3. Exercise 3 says to use the value of the discriminant to determine if the trinomial can be factored. So there are a bunch of them to choose from. Let's just do B and C right in the middle. C looks really tough because it's got that square root sign in it, but don't be afraid. Okay, so the first thing I'm going to do is I'm going to write down the discriminant, b squared minus 4ac. And I'm going to do that just to be reminded of what I'm looking for. It's that piece of the quadratic formula that we looked at here that said that because it's in the square root sign, if it's positive, there are going to be two solutions to this. If it's 0, the solution is going to be simple. It's just minus b over 2a, which means there's only one solution. And if it's less than 0, you can't take the square root of a negative number and there'll be no solution at all. And then we also said, although it doesn't say in the book, bad book, that if the discriminant's a perfect square, then you're wasting your time with the formula because it can be factored. Yes, you can factor a trinomial if the discriminant's a perfect square. You can factor a trinomial if the discriminant's a perfect square. You can factor a trinomial if the discriminant's a perfect square. Did I mention? Whatever. Okay, so let's look at B. B is 11x squared minus 9x plus 2. So the discriminant then is b squared, so that's minus 9 squared, 81, minus 4 times a times c, minus 4 times 11 times 2. And running that through here, 4 times 11 is 44, times 2 is 88, so 81 minus 88, and that's negative 7, and we can't have square root of negative 7, so we can't have a solution. So B, there is no solution. Don't bother wasting your time trying to factor it because you're never going to go anywhere with B. Let's look at C. C is a bit of a challenge. C looks like this, 2x squared minus 2 root 6x plus 3 equals 0. So in attempting to solve this, we will go b squared minus 4ac. So that thing there, b is minus 2 root 6 squared minus 4 times a, which is 2, times c, which is 3. So that second half is easy. 4 times 2 times 3, that's 8 times 3 at 24. That part is a little bit more difficult, but we can remember from our exponent rules that if we've got this stuff in here, this times this, we can just square them both separately and then multiply them together again. So minus 2 squared is 4, root 6 squared is 6, 4 times 6 is 24. So 24 minus 24, and the answer is 0. So the discriminant is 0. The discriminant is 0. 0 is a perfect square. Therefore, this can be factored. And therefore, we did not need to worry about using the quadratic formula. Now, the question is, this can be factored? Look at this. It's a scary nightmare. Well, let's try to factor it here. If we do factor it, it's going to look something like this. And we know that because this is negative and this is positive, they're both going to be negatives. And these two terms here have to multiply to 3, and these two terms here have to add to negative 2 root 6. That sounds horrendously complicated. So here's what I'm going to do for starters. Let me simplify all this. I'm going to get rid of the 2 and the 2 there by taking the entire thing, both sides of the equation, and dividing by 2. And if I do that, my new equation is x squared minus root 6x plus 3 over 2 equals 0. That was just a division of the entire thing, both sides by 2. Now this is a little bit simpler and a little easier to work with because there's an x squared here. Whoops, nothing there. And there's an x here because x times x is x squared. No choice there. And these two have to multiply to 3 over 2. They have to multiply to 3 over 2, and they have to add to negative root 6. Well, the only two things that will add to negative root 6 is negative root 6 over 2 and negative root 6 over 2. Now we can see, does that work? X times x is x squared minus root 6 over 2 minus root 6 over 2. So we're minusing halves, and so there, yeah, minus root 6. And the question is, does root 6 over 2 squared equal 3 over 2? Well, let's see. Root 6 times root 6, 2 times 2 equals 6 over 4, which equals 3 over 2. So yeah, it does. And I knew it would, because according to this rule, if we end up with a perfect square trinomial, or sorry, if we end up with a perfect square discriminant, then it is indeed factorable, and I knew I was on the right track.